Okay, so is
Okay.
it recording?
Wait. Yes, it's recording.
Okay.
Okay. Hello, everyone, or who is like, seeing this recording. I'm Lakush Pranu, B19118 triple E B batch. This is my team.
I'm Elsa George, B191034EE.
And I'm Srinaran Jadathan, B190520EE.
Hello everyone, and I'm Anurag Singh, B191040AA.
And I'm Siam Francis, B190296W.
Uh, we're holding a group discussion on the topic of state space analysis. Okay, which one of you guys would like to start?
Uh, I think we need 5 to 6 questions. Oh, 5 to 9,
No, no,
right? Like we can
yeah,
ask each
I
other.
have two. I have like three questions. I'll ask random people. I don't know.
Okay,
Someone.
okay. I also have like 1, 2 questions. Yeah.
Okay, huh? Wanted to ask.
Mm,
Okay, I'll ask a question.
Yeah, sure.
yeah.
Uh, so, Jatartan,
Okay.
so what is state space averaging?
Okay. So state space averaging is it's basically the switching circuit divided into 2 or 3 different structures. So the derivatives of inductor current and capacitor voltages are defined based on the circuit theory. So these currents and voltage are averaged over one switching cycle. So that's basically the state space averaging.
You can also mention that like for state space averaging, it's like basically if you have one system and you have another system which is similar to the system, you could just exchange the variables in the current system to recreate another system.
Yeah.
Essentially,
Yeah.
Thank
uh,
you.
Anurag. Anurag, I'm asking you. Let's see. Which one of the three do you want? Choose a number, one to three.
One.
One. Okay. What is functional analysis?
Functional analysis. Yeah, functional analysis is basically it is study of vector spaces, and it is functional analysis is study of vector spaces and with some kind of limit related structure. Like example, inner product is there,
Yeah.
norm, topology, that kind of stuff, and these functions such as it is used as Fourier transformations like continuous, unitary, etc.
Very.
And most of this is useful for the study of differential kind of stuff, and
Integral
integral
also.
and yeah,
Yeah.
integral equations, differential. For that, this functional analysis is important, and that's why we study it.
Okay. Wait, now you ask. We play like Russian roulette. You ask a
Okay,
question. Someone.
I'll ask a question to you, Lavkush.
Oh, okay. Revenge.
Uh, so tell me, how do you determine how many state space variable are required for an equation?
Okay. So basically, if an equation has like of is a second order differential equation of sorts, what you can do is you can list out all the variables which are present, and then you can list out the dependencies of each variable. So, for example, say we took the standard spring system, right? What we could do is we would have, or any mechanical body. Basically, what we have is we'll have position, we'll have velocity, and we'll have acceleration. So the only two factors which you'd ever need is only velocity as well as position, because acceleration is just a byproduct of force, which is essentially position changing at like a rapid space. So this would be like a second order differential equation, right? That would be like A is x this thing dx square by dt square. So essentially, what would be there is just a second order. So you'll only need two what state space variables to define this system essentially.
Okay. Next.
Yeah, I'll ask one to Elsa. Uh, what are the advantages of modern control theory?
Can you repeat the question?
What are the advantages of modern control theory?
Okay, so
Advantages.
a modern control theory, it's basically like it converts the differential equations into like a system of lower order time domain equations, basically state equations. And from there, we can actually manipulate using techniques from linear algebra. And when coming to the advantages, uh, using the modern control theory, we can actually analyze time varying, time invariant, linear, non-linear, and like single multiple input output systems. So that's one advantage, and we're able to include initial conditions. Also, like optimization is a lot easier, especially optimal designing, and these are like we can confirm the state of the system parameters, and it's not just the input output relations. So I think that's it.
Mm, yeah.
Okay, so Jitarthan, I was asking you, what is linearization?
Okay, so linearization it involves creating an approximation of nonlinear system, which will be valid for a small region around an operating point. So in like a steady state condition in which all model states are constant. So that is basically the linearization.
Okay,
So uh,
nice.
I have a question. I'll ask Anuja.
I
Uh,
think you can ask Steven. Steven didn't even answer any question yet.
when has an
Yeah,
answer ready, right?
Yeah.
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 Can't
Okay,
escape
so
easily.
what's a phase plane analysis? Can you like elaborate
Uh,
a little?
yeah, sure. Stage plane analysis basically, a graphical method
Space
to,
plane, not state space.
yeah,
Yeah, yeah, yeah. That's what it is.
Okay. Okay, I got
yeah.
stage. No, let's continue. Let's continue from here.
It's fine.
It's fine,
It's
it's fine,
fine.
it's fine.
Okay, fine. Phase plane analysis basically, a graphical method for studying the second order systems respect to initial conditions by providing motion trajectories corresponding to various initial conditions and yeah.
Any disadvantage to phase plane model?
uh, yeah, like the graphical study of higher order is pretty complex, I guess. Yeah, that's a disadvantage for that.
Mm-mm.
Yeah. Um,
Then
no,
wait,
you ask someone.
I'll ask Anurag.
Okay.
Like,
Okay.
why is it an advantage to put equation into state space form?
Advantage to put,
Into state
like
space
why
form?
is it advantage to put equations in
Yeah,
state
in
space
state
form?
space form.
Yeah,
Yeah.
like
Yeah, yeah. It is
normal
obviously
transfer
an
function methods better, right? So
yeah.
why do you need state
I mean,
space?
obviously, it is an advantage because this technique can be used for linear and non-linear both. And again, this can be used for time variant and time invariant system both. So this is obviously an advantage, and it is also easier to apply where Laplace transformation cannot be applied. So it is better than Laplace transform.
Hmm.
So yeah, to and another.
Another
So
thing is
this,
also because state space models, right?
yeah.
Like I said before, you can substitute them to form new models with easily. Now, all you do is just change a few variables, and you can like create a whole new model altogether. So like into like
Okay.
multiple models. It's pretty cool, actually.
And another thing is like this, like let's say you have an nth order differential equation, and
Mhm.
in order to solve it, like what we, with the help of this thing, we can change it nth order differential equation into n equations of first order. So
Yeah, yeah.
this is easier to solve. So it really helps.
Okay.
Yeah.
Okay, I'll ask one to Lavkush.
Okay.
Like, how's the system analysis for standard spring system?
Okay. So standard string system is, say, for example, you have a block object and you have a spring attached to it,
Hmm?
and it's attached to a ball. Now, the only force being applied on this block is from the spring. So that is the force would be like k times x, which is the distance in which the string is compressed, and that is the force applied. So acceleration would be equal to this. So, like I said before, so you only have like two variables required. So you only need the velocity of the block which is moving and the displacement of the spring,
Yeah.
because and you can directly build a simple second order system itself instead of needing a third order system, like three state space variables required for to display the system. So it helps in like making this simpler and faster.
Yeah.
Okay, Elsa, what are the disadvantages of open loop control systems?
Okay, open loop control systems, they're basically like no feedback system. So a lot of the disadvantages have stuff to do with it because the output depends on the input, but then the input or the controller is actually independent of the output. And because of that, they're unreliable. And if there's a change in the output, it cannot be corrected automatically because there is no feedback. And because of that, it's actually very inaccurate. And open loop systems, control systems are like the bandwidth is relatively lesser, and the process of automation is not like really facilitated in case of a non-feedback system. I think those are like
Yeah, non-feedback
the
system essentially.
disadvantages.
Yeah,
Yeah,
that's enough, right? Like
yeah. I
what
think
we
we're
did.
not,
That's like
not left anyone out, right?
around
Everyone.
12 questions we did.
Uh,
Yeah, so
Like,
should we end this call here?
yeah,
Yeah.
I think
Yeah.
like,
I couldn't hear in the middle for a while. This thing,
Oh,
this
okay.
campus network.
Yeah,
Yeah.
Yeah, just
Okay.
went for a while.
yeah. But I think we all
Okay, cool.
have like a good understanding of stuff when
Yeah.
it comes.
Yeah, yeah. It's
Okay,
actually
guys.
good. Yeah.
Yeah, it seems
Okay,
like
guys.
everyone
Then
understood the topic. So
Yeah,
yeah.
everyone kind of answered like. Which,
Yeah. Okay, so
okay,
next
bye,
meeting, I
finish,
guess.
done. Okay,
Yeah, yeah.
leave.
Bye, bye, bye.
yeah.